Hello friends, today I am going to discuss about what is unevenness, how to measure it, okay, how to measure it at site, also how to correct this at site. So these things we will discuss in today's topic, okay. So unevenness means what? Undulations or dips in one line, also called as longitudinal level, measured separately for left rail and right rail. Okay, so you have two rails like this, so you focus only on one rail, right? So if you see next picture, see here, so this is the picture. Okay, here you don't have any unevenness, surface is even, surface is even, right? If you see this picture, okay, all these were for one rail. Okay, so if you see this picture, you have a track like this and then you got something like this, right? And if you see this picture, you got a rail like this and you got something like this, right? Actually it should be like this, but it has become like this and like this. So this is called sag. Okay, this is one form of unevenness. This is called hump. This is also one form of unevenness, right? Now we have to make this sag and hump to this non-undulation or even surface track, right? That's what we have to do, right? So I hope from this it is clear about unevenness, right? So if you go further, now next is how to measure this unevenness, right? How to measure this unevenness. Okay, so if you come here, see, this is a even surface, it has no unevenness, right? But this has unevenness, right? Now you have to measure the magnitude of unevenness. For that, what you have to do, you have to see the rail, sight the rail from long distance. See, approximately 30 meters to 60 meters distance, you see the rail along the head like this, arrow direction, right? And after seeing, you will observe, okay, some good portion, okay, even portion, then disturbed portion. Okay, this is a disturbed portion and this is a even surface, good surface, right? These things you will see when you sight the track. Now after that, what you have to do, you hold one cord means thread, you hold one thread from straight portion or good portion to next good portion. So this is a good portion and this is a good portion, you hold one thread like this. Now you measure what is the distance this between this thread and the rail surface at a different levels. See, at the 3 meters here, what is the gap? At 3 meters here, what is the gap? At 3 meters from here, what is the gap? At 3 meters from here, what is the gap? Like this. So every 3 meters you start measuring the gap between cord thread and the rail surface, right? Now in measuring stage, you will have a data like this. So every 3 meters, every 3 meters you have this detail. So highest is 40 mm, right? So the highest to which the rail has to be lifted is 40 mm. So here see, from this level, this rail is 5 mm low. From this level, this rail is here 40 mm low. That is the meaning of this 5, 10, 20, 30, 40. So now at site you should mark these details. Okay, you should mark these details, right? So now you got details about what is the maximum value of sag. You also got what should be the value with which track has to be lifted at every 3 meters. So this data is ready with you. Next, once this data is ready, you have to go for correction. Now how to do correction, right? For correction, okay, you should take these points into consideration. Based on this, which one you have to adopt, that you take, right? First, magnitude. See, maximum you got 40. Suppose you get 10, 15 like this. These are has very less magnitude, and this can be done directly. Now what does that mean? I will say you, right? And see, next, suppose you got a line block. Suppose you want to correct this portion, right? So this portion you want to correct. Okay, highest is very less. Okay, magnitude is very small. Then you can do it directly, right? Next, if you have some block available to correct this portion, they can then you can do it directly. Suppose you have 40 maximum, then also you can do it directly. And one more thing is, if you have sufficient time, so before any train comes, you can complete this, right? You have sufficient time to complete this before any vehicle arrival in this portion. In that situation, in this three condition, you can directly complete that work. Otherwise, you have to go for gradual lift or stage wise correction, right? So what does this mean? We'll see here. Now here you want to to bring this entire level to this red portion. You have to lift here 50 mm, you have to lift here 10 mm, you have to lift here 20 mm, okay, you have to lift here 30 mm, like that you keep on lifting, right? So what I told you, no train will come if you have sufficient time, so that you can complete this portion, you can complete this portion, complete it, right? Or you have enough block, you have block given, or if this magnitude is less, in that condition directly start making it 0. 5 you lift it to 5 mm and bring it here, 40 you lift it here and make it 0. And once you complete this entire portion, then only you have to pass the train, otherwise you should not pass it. That is one case, this is one case. Otherwise, suppose you have a portion like this, and after correcting up to here, now suddenly train started coming, then, right? So in if this is the situation, in this case you have to go for stage wise correction, okay, stage wise correction. So first case, you can, if you, in first case you can directly start lifting it and complete from one end to other end, complete from this end to this end. But in stage wise correction, you are not going to take entire 40, you will not correct it entire 40, but you will do as shown in figure below. See here, what you will do, you will first, now this black color is the initial position of the track. Now in first stage you will lift up to yellow color, this position, and you will pass the traffic. In next stage you will bring from here to here, in next stage you will bring from here to here. So first here, then here, then here. So here you will not do it at once, you will do first, then second, and then third. After three stages only you will bring the track to initial position. This is called stage wise correction, right? So why this stage wise is better? What will happen if you don't do stage wise correction? So that I want to explain you. See here, suppose now this is the position of your track, right? Now you started correcting, you brought up to here, right? You brought up to here, you brought up to here, and you have completed up to here, right? So now suddenly train started coming, Hmm? Now at this location, this point is 0 mm, and if you go further nearby station, you have 40 mm. So it is like this, right? It is like this. Here it is 0 and here it is 40. And when train was coming, this situation, sudden variation situation is very dangerous. Creates a safety problem. This situation is very dangerous, right? So that's why we have to do stage wise correction. So instead of completely lifting entire 40, you will first lift 20, then 30, then 40. Okay, so this is what we have seen. Understood, right? So this is the initial position of the track, and see, after correcting to certain length, there was sudden drop. So this is dangerous. So this to overcome this situation, we go for what? Stage wise correction. Suppose you have enough time, then you can complete like this. But if you don't have enough time, or you have to immediately pass the train, then don't do entire lift, do only, okay, small lengths, right? Understood or not? So next, see, so see, suppose you are here, right? When train comes, the difference between this point and this point is very less. But suppose you have connected to full length, so distance between gap between this point and this point is very large, very large. So this is less dangerous compared to this position. Okay, this is dangerous. That's why, okay, this stage wise correction can be adopted if magnitude is high, right? Magnitude is high, that can be adopted. That is one thing. And suppose you want to make, suppose you have lifted it 0 and this was at 40, and still you want to pass the train. In that condition, at least you should give the ramp. See, 0 I brought it to 10, next 20, 30, 40, and I have connected a smooth connection between 0 and 40 level, 0 and 40 level, and after this you can pass. So this is called ramp. This is called ramp. So see here, initially your track has unevenness of 40 mm like this. After correction you make it like this. So this is what unevenness correction is. So overall, the main thing, whether you go for stage wise or direct correction, that you should be clear. Okay, stage wise you don't have much safety problem. Still, if you have some safety problem, then you can provide a ramp. But this one compulsory, you should have block, or okay, you should have safety time for correction, right? So this is regarding unevenness. So if you see the picture, see, suppose your track has like this. What you do? You lift here, you lift here, you lift here like this, right? But it should be done in a gradual manner. Okay, thank you friends, thank you for watching.